I'm going to show two examples of solving systems of linear equations with their application. So let's look at the first ones. We've got a plane that's flying from Honolulu to Kahului on Maui. So going against the trade winds, that plane is fighting against the wind. So here's our little plane. And so if we let the p equal the speed of the plane in still air and w equal the speed of the wind, on the way towards Maui from, let's see, we're going from Honolulu towards Maui. So the wind is coming, the trade winds are coming, and the plane is having to fight against those trade winds, right? That wind is kind of just pushing the plane back just a little bit. So the speed the actual average speed that the plane is going would be its speed, true speed in still air, and then it's fighting against the wind. So the wind is slowing it down just a little bit. Okay, now the big key with these types of problems is that distance equals rate times time. So the distance that it's traveling is 90 miles, about 90 miles, and then the time that it takes is 30 minutes. Let's see, we're going to need to find the average speed of the plane in still air and then the speed of the wind. And our units need to be miles per hour. So 30 minutes, I'm going to just rewrite that as a half an hour. So our time here is 1/2. Now going the other way, so going from Maui and heading back towards Honolulu, we've got our plane is being sped up just a little bit, not a lot, but that wind is helping. Okay, so we have the same distance that we're traveling, but now we have the plane, if it was flying in still air, and then it's plus just a tiny bit of hint of that wind pushing it along. And it's taking just 20 minutes. So 20 minutes, if I'm trying to convert that to hours, I would say that 1 hour is the same as 60 minutes. And so then that would be the same, just multiply. We would have 20 over 60, which simplifies to 1/3. And that would be in hours. So I'm going to write my time in hours. And now I have a great system. It looks like I can do addition method here. But I'm going to simplify on this one. I'm going to go ahead and just multiply both sides by 2. And on this one, I'm going to multiply both sides by 3, just to clean that up a little bit. So multiplying both sides by 2 here, I get 180 is equal to p minus w. And then I would have 3 times 90 is 270. And that would be p plus w. And now I can use our addition method. So we go ahead and add columns. And so this would give me 450 is equal to 2p. My w's would just add up to 0. And so p is equal to 225. And that would be the average speed of the plane in still air. It's a little slow. Usually these inner island planes are flying more like 300 miles per hour. But it's average, so it's including the takeoff and landing speeds when it's slowing down a little bit. All right, now we can use one of these to help us figure out our wind speed. I'll go ahead and just use 270 is equal to the plane speed, so 225 plus wind. And solving for W here, I would get that the wind is 45 miles per hour. All right, and then writing that out, we have the average speed of the plane in still air is 225 miles per hour, and the wind speed is 45 miles per hour.